DK, you got a question? Some other students also have some questions. Guys, we'll get those answered. Rena, remind me, did we sort of finish up that handout? The one that you were reading from the, for the parabola and pergola? No, was there more on that besides the conics? That was it, wasn't it? I think we sort of finished that up. Guys, I'm looking for, hang on. But here's what I want to do. I've got math induction in front of me. I've already said, do not worry about math induction on this final. We went through what? We went through, I think, one nice one yesterday with math induction proof. They got one that's a little bit crazy on us. So at least you've heard the words math induction and have a sense of maybe what to do if you see one later on. But I'm always responsible for this. Conics, the most simple. I mean, most simple. Maybe I should graph or make a quick sketch of a parabola in that form y squared is equal to 4cx or x squared is equal to 4cy, like we derived here today. Something very simple. Okay. Now what I'm concerned about though, June, you help me out. She said, Professor, we've never seen an exam or a quiz on maybe sketching the graph or the trig function where I use bounding as my technique, and then found the period and the amplitude and all that business. She said, yeah, we've talked about it, of course, but we have not been tested on it. Well, I figured some items like that also today. Now though, my students probably have questions. PK, tell me what you saw on one of those handouts. Let's get that one out of the way right now.
2y.
Okay, 2y. Okay. Raised to the fourth. And she said, Professor, the question is, can I rewrite that in or use the binomial theorem? You guys. So she said, Professor, express this like this. And we'll start with 0 here, and I guess go through 4 there. You guys agree? The way it looks right now, at least the lower limit and the higher limit, we always start with 0 for the J. Now, can someone help us out? If she wants to just express, we may not actually, like, I may write the first one. What does it look like? And the direction said use the binomial theorem. Now, this could be something like this, ask you to do, just write out a few of the terms. So this is very appropriate. What may it look like?
4 divided by 4.
Well, what goes inside here? You got N choose J, don't you?
Yes, yes.
Okay, you gotta put that in.
0.
You gotta put that in. Then what else? Based on what we've experienced with binomial theorem. I think I bring this term here in. The 2y coming in next,
Yes.
right here. And what should that be raised to?
-1.
4. Yeah, okay, that's why I used it. In her case, it's what? 4 subtract what?
J.
J. That's your guy? And what might the last term look like?
-3.
-3. I'll put a -3 in there. Raised to the what?
J.
Okay. Now, if that's written correctly, and it looks like it might be, who on earth would think that this mess, all this, we'll get the same answer as if you multiply this out. 2y subtract 3 times 2y subtract 3 out 4 times, and be patient and go through it, you'll get the same answer. PK, let's look at that mess there, see if we agree with it. Let's write out at least the first term. Guys, I know the first term should be, help me out, if you were doing it algebraically, 2y subtract 4 times 2y subtract, not 4, 2y subtract 3, 2y subtract 3 4 times. Tell me what the first term in your final expansion would look like.
8y.
How much? I think it's gonna be 16. Is 16? Just the first term. 16y to what? Fourth? So let's use this now and find the first term. And see if the first term looks like it's 16y to the fourth. With me, guys? Okay, here we go. This is 4 choose 0. First term here. 2y raised to the 4 subtract 0. Negative 3 raised to the 0. If you guys agree, is that the way the first term would look? I don't know why I put that fractions there. Is that the way it looks, this written out at the first term? When you start with j equals 0, yes or no? This 4 choose 0, you might think, we'll find out what it is though, it's 4 factorial over 0 factorial over n minus j, in this case 4 subtract 0 factorial. Guys, that's the formula. N choose j. I think I'm going to end up with, if I finish this up, I think this is what, 4 times 3 times 2 times 1, help me out. 0 factorial, of course, is 1. And then about, what was this over here? N factorial, j factorial, n minus j factorial. Is this 4 factorial here again? Is all that written correctly?
Yes, it's just.
Okay, that looks like everything's going to cancel into a what? 1, which we would expect. So hold on now. Guys, this is all 1 PK, I'm glad you asked. That's 1. Done. Now this is just algebra. It says take 2y and raise it to the 4th power. Is that 16y to the 4th? Done. This raised to 0 is 1. Do I really end up with, in fact, I'll put that 1 on the end, that's for negative 3 raised to 0. Do I really end up with 16y to the 4th for the first term like we thought algebraically you should? Even if I use the formula.
Yes.
Okay? Let me write out one more term and see what it looks like. Let's write out the second term. Okay, I'm gonna stop this. The second term would be j is equal to 0 first. Now j is equal to 1. That's 4, choose what? 1? 2y raised to the 4 subtract 1, and negative 3 raised to the 1. Guys, see if that's written out correctly, if you agree. Is that what the second term may look like written out from the binomial theorem?
Yes.
Okay, let's see what it is. 4 choose 1, we gotta use formula. 4 factorial, 1 factorial, 4 subtract 1 factorial. That's all given in class yesterday for a formula. Let me finish that up. At 4 factorial, of course, it means this. Bottom part, 1 factorial is not exciting, it's just 1. 3 factorial means this on the end. I'm doing it fairly quickly, guys. It looks like all this cancels. And now it looks like, I'll bring it over here, guys, looks like the first part is merely a 4. There. Now this says 2y cubed. What is 2y cubed? 8y to the 3rd. And negative 3 raised to the 1st. Negative 3. Oh boy, PK, did multiply all that mess together? Are we okay, guys, on that?
Negative 96.
Or the negative 96?
Y cubed.
He's telling me it's that for the second term. By the way, how many terms should there be altogether if we wrote all of them out? Nuh-uh. 5. Should be 5 terms. I wrote the first 2. So I may ask you right up maybe the first 2 terms or first 3, just to see if you understand how this binomial theorem. Now guys, that's a strange number there. If I were you studying tonight, I would go ahead and say, I'm gonna do this algebraically. I'm gonna multiply this out, Professor, algebraically. And then check my second term when I finally finish it algebraically and see if it agrees with the binomial theorem. Okay? Woo! PK, are we okay there? Think so? Okay. And that's what they want you to do. Now I'm gonna take questions from students. What else are we concerned about besides this binomial theorem and working it out? In June, we'll have your notes out for you guys to look at. She does such a good job on all this. Okay. Anything else that my students may have concerns about? Would you like to see a copy of the test? Then you can have some questions, right? Oh, wouldn't that be nice to pass out that 12-page test? Oh, I saw eyes open up right there. Oh, I saw some eyes up one time, and I said 12 pages. Oh, it's not 12 pages. It's quite a few pages, not 12. Okay, guys, if you don't have any questions.
So if the expand using the binomial theorem, you have to show like everything.
Yeah. Now, I doubt if I would ask you to completely do it, because you got, this is the first term. I did the second term. This thing has 3 more terms. So I'll probably just ask you to write out the first 2 terms. Just to make sure you understand how that binomial theorem works. It's interesting that that second term is negative 96. I hope algebraic, if you did middle school, I hope you did negative 96 for your coefficient in that second term. Guys, now I'm concerned about, as June told me, the tree. And I went to my office during the break, and I tried my best to find something that maybe I could bring in. I was really looking for one of my old exams that covered the tree. And with these solutions, that's what I was trying to find. And then you can see how it's approached or how it's written. Yes?
Would the fifth term, that one be -3 to the fourth?
You mean all the way down the end down here?
Yeah.
It would be. We've got -3 raised to what? The 0, 1, 2, 3, 4. -3 raised to the 4th. It would be. Okay? Okay, let's do this. Hang on. I brought in, I don't have copies, it's just me reading here to help you here. Guys, first, you'll see more than likely something like this for the tree. Given cosecant is equal to -3, comma, and secant theta is greater than 0. Find, here it goes, sine theta, and all of a sudden, sine double theta. Find cosine theta, and all of a sudden, cosine double theta. And then tan, I could do tan, but we'll get the idea right here, I think, on this one. Guys, look at it. Help me out. And in fact, in my directions on the test, I may say use the identities. Use the formulas in your approach here. As cosecant is -3, does anyone realize where cosecant is negative? Wonder why? Where is cosecant negative to begin with? Which quadrant? Because I gotta locate where this angle is. It is 3 and 4. Do this. Clarification here. Does anyone remember where secant, which is 1 over x, where is it positive? Greater than 0. 1 and 1. 4? That's your guys? Secant is positive in 1 and 4? And they match up therefore in, or what was it, quadrant 4? So this angle is located in quadrant 4 through that reasoning, and that means we have this to help us for the signs. First, you gotta locate where we are. We're in quadrant 4.
We can find sine easily.
Okay, now if you say find, beautiful, I got it. If I say find sine theta, not double theta, just regular sine theta. What's gonna make it so easy? I think he's telling me that cosecant, professor, by an identity, is what? 1 over sine. In other words, they are reciprocals. So since I gave you cosecant as this, you really take the reciprocal, and you got this one out of the way. Easy done. But I may ask for that justification. I'm gonna say, please tell me which identity you were using. In this case, cosecant is equal to 1 over sine. Now, if I actually find sine double theta, which I will, that's a little bit more work. That's going to require a formula. Okay, and does anyone recall the formula for sine double theta? Right here, 2, what, sine theta? Cosine theta. And even at this point, if I use that formula, I have 2 times, we just discovered sine theta is negative 1/3. I can put that in right now. That's why I arranged it like this. Cosine's missing. I need to find cosine. And in fact, was I asking for cosine down here?
Yes.
So let's jump down here and get this out of the way and bring it back up.
Add 1 minus.
Oh, I got you. You're saying about Professor, sine squared plus cosine squared is equal to 1. And some of my students are even telling me quickly another way to say it. But this is the basic identity. Sine, we've already discovered is negative 1/3, and put that in.
Square root of 10.
Absolutely. Oh, you got the, hang on. That's 1/9. Let's take that over or subtract it. Guys, looks like it might be 8/9. See if you guys agree. I did real quickly. Then do a square root. And I know if that square is staring at me. Right now it's plus minus, and that's 2 radical 2 over 3. See if you guys agree. Now that's a cosine. Now I have to decide which sign to use, positive or negative. I'm in quadrant 4, so should cosine be positive?
Yeah.
So that says erase that. Now you have cosine, and you have another thing answered here. Now let's go back up and finish this up. 2 sine theta cosine theta. We just found that to be this. I put everything in there correctly. And it looks like it's going to be a negative answer. Negative 4 radical 2 over 9. See if you guys agree. Is that sine double theta?
Yes.
Woo!
Not cosine.
Oh, I haven't done it yet. But is that sine double theta? Done. Now cosine, you got a choice. You got to know your formulas. You may say, Professor, one formula for cosine double theta is that. And if you're going to use that one to get this answer, you could. Or I've seen some students say, no, Professor, I like this one. Sometimes it depends on what's being asked. And some students will say, no, I prefer this one. Okay, so you get to decide, and all those have been discussed in class. I'm going to use the first one. To find the answer, I need to square cosine. We found cosine in number 3 to be that strange 2 radical 2. I think it was over 3. That's being squared. And subtract from that sine, which we found to be a negative 1/3. And that's being squared. Let me step to the side there and make sure I put all that in correctly. You guys agree? Clean this up. I think this squared is, help me out, 8 over 9. I think. Is it, guys?
Yeah.
Okay. And it says subtract from that 1/9. What is it, 7 over 9? And there's the double, cosine double theta. Yes or no? I did it quick. Okay, now let's check here. I can't tell here because I'm asking for a double theta. I just know where theta is located. You gotta be very careful with your signs. That's a good question though. Because we get positive or negative, double theta. Okay. Now, could you do something like that for me? I'll give you the information, find sine, cosine tangent, or cosine double theta. I'm not gonna ask you, Nikki, for cosine triple theta. I didn't give you a formula for that. Okay, so you guys can do this. That's one of my concerns for the test tomorrow. Another concern was, and I think my students who showed up at 11:30 this morning had one, and I may have brought another one in here to look at with you guys. The trig, and that is, here it goes. Oh my goodness, I think it's the same one we may have done at 11:30. You guys who were with me at 11:30 can assist me if I get started here. I want to sketch one complete cycle of this trig function. Y is equal to -3. And it looks like it's cosine pi over three, subtract two x. I got j. You guys who were with me at 11:30, is that the same problem? Okay, so you can benefit or help me if I start making mistakes here. We're going to sketch one complete cycle of that. And I will say, just sketch it. If you do it through transformations, and some students like transformations, go for it. I'll probably do mine here by bounding, that we discussed in class. But first I need to clean this up. So first we're going to rearrange what they call the argument. We'll put that x term first. And have it look like that. And then I think the suggestion this morning, and I'll do it here also, is to do what in addition to that? Inside there. Go for it. Who has it? What did we do this morning? We took out the -2. Factor out -2, got the x completely by itself. And be careful, I think this looks like this. And if I use a distributive property, that will certainly take me right back to this. So that looks good. So guys, inside there, we're looking at this. Now, you guys who like transformations, go for it. What you have to do if you want to do transformations, you got to first place the parent graph. You got to reflect it across the x-axis. You got to vertically stretch it by 3. You got to now reflect it across the y-axis. And that 2 there made me a horizontal what? Shrink or stretch you got to worry about. And then finally this right here tells you, in addition, you got to do a horizontal shift to the right, pi to 6. You want to do that? You want to do it? Each one of those transformations, show me each one of those transformations. You can now. I'm not going to hold you back. I don't think I do. What I want to do is, first, Marina, I think you're the one who mentioned this morning. Cosine has been identified as an even function. So to help myself out before I jump into the sketch, could I, for an even function, drop that negative sign inside there completely? Not the negative sign out front. And rewrite this as -3 cosine. And now inside here, we have this. And think of the function as looking like that. Is that what we did this morning? You guys were with me. Okay, so watch out for even, odd. And just out of curiosity, I don't have the time to do all of these, but if this has been sine has been identified in your notes as odd. If that had happened on sine, this does not drop out, but you may move it out front. In this case, that would change that to a +3, and then graph it. How am I going to graph it? I'm going to bound this. Now, one of my students in one of my classes here, this class, asked, Professor, can I always bound it between 0 and 2 pi? Can I always bound it if I'm desperate, everything between 0 and 2 pi, even though we bounded some of the parent graphs differently? Of course you could. You may have to modify it a little bit to get the full graph. The cosine graph, if you look back on the cosine parent graph, we did start at 0, went out to what? 2 pi. Same thing here. It's bounded like this. Caught between, this part here, caught between 0 and 2 pi. The parent cosine graph, I think we had it caught between 0 and 2 pi. The parent graph for sine between 0 and 2 pi. I think tangent we had different bounds. Does anyone remember, just out of curiosity, what the parent tangent graph, what did we choose for the bounds? I think we went from -5/2 to a +5/2.
It was
Back
part
to
of
those.
it.
That might be the bounds if this had been a tangent graph. But if you say, Professor, I can memorize all those, you wouldn't really have to. You can bound it always between 0 and 2 pi, but you gotta be careful and get the graph you're after. Okay? This will be fairly easy, I think. Okay, divide by 2. Get this. Add pi over 6 to everything. Do not let me make a mistake. And guys, by the way, when I reach this point here and add pi over 6, I think I end up with what, 7 pi over 6 was it? You guys at 11:30? I think those are my bounds on this graph that I'm looking for. tree graph sketch for you. Yours may be a sign tomorrow. Well, it could be a tan. Could be a secant. Oh, secant, that's a little tougher. We did all of them. Okay, guys, let's see what this might look like. Let's go to the grid. And place what we can on here. Gia, I know it's gonna start at about 5 or 6. And I know it's gonna end at 7, 5 or 6 out here. But there's some intervening points missing to get the full cycle I'm after. Now, does anyone remember what we did as a routine to find the missing points in between? We found the period first. The period should be the ending of the cycle, which is 7, 5, or 6. It's in fact the beginning. Okay, guys, I think we ended up 6, 5, or 6, which was pi. So the period is pi. That's my repeating number. But what do I do with that before I go back and place what is missing? I divide by 4. Why 4? We usually have 4 quadrants, right, on the graph. So take this period and divide, I'm about spacing. Space, take the period and divide it by 4. This is a good example to look at. What it means is, you that period divided by 4, you go back and start adding pi over 4. The awkwardness about this one is, I've got a 6 here and a 4 there. So to make it not so awkward, let's use a common denominator of 12. Let's call this spacing 3 pi over 12, which is still pi over 4. And then this, 2 pi over 12, much easier. And down here, I guess 14 pi over 12. Is that true, guys? Now let's start our spacing. So I'm going to space by 3 pi over 12. At the beginning, if I add 3 pi over 12, it takes me up to 5 pi over 12. Add 3 again, 8 pi over 12. Add 3 again, 11 pi over 12. That's critical, what I just did there. What else should I mark on the grid? Just by observation, I know something about this 3 here. 3's involved. So let's go up to 3 in case I need it. Down to a -3. Now I should be ready to sketch it. Okay guys, this is a cosine graph. Keep in mind, please keep in mind, all this is done, you don't have to look at this anymore. PK, that's gone. All you need to worry about to get your sketch is, what does this mean is happening? This means my cosine graph is upside down. It's been reflected through the x-axis. And it's stretched by 3. So if it's upside down compared to the parent graph, please remind, or tell me, is it going to start down here at its beginning, rather than up here like the parent did? Make sense? Next point over, it should, I hope, cross the axis. Next point over, it should go up to 3 finally. It's upside down. Next, on the axis. And finally, back down to a -3. And your graph would look something like this for one cycle. And I'm happy, you're happy to just get one cycle. And it's got to be labeled, just like I have mine. Guys, everyone with me? This would be a good one to look at tonight for study. Domain of the function, I notice I'm going to write this like this with a subscript of f. I want the entire function, not just that one cycle. Since those cycles repeat forever, it's open. Everything. Range though on the function, it's going to go from a -3 up to, what's that, +3? Amplitude, the highest point from the axis, is 3. Period, I think we identified earlier, period was pi. The truth. Let's step back and look at it. You guys agree? Now, I will ask you, I'm gonna choose a point for you, probably. I'll choose one of these five and ask you to algebraically show me by substitution what f of, going back to my function, f of, guys, let's try this, 14 pi over 12. We're going to reduce it down. What's that, 7 pi over, was it 7 pi over 6? I think. Look at it, 7 pi over 6, it's 14 pi over 12. Go back to the original blue, original function, and put that in, -3 cosine, here goes, pi over 3, subtract 2 times this, close that up, step back, make sure we put it in there correctly, on the blue. Clean this up, -3 cosine, guys, inside there is pi over 3, subtract, if I do a little canceling here on the end, I think it's subtract 7 pi over 3. Watch out for mistakes I can make on the board. I think it is. You guys agree? So it's -3 cosine, I think inside there is a -6 pi over 3. Which is, I'm going to do it right here, -2 pi. Is that true? Now, woo! Cosine is an even function. If you don't like that negative sign, my goodness, even on this, you can drop this. Even on this. This cosine has been identified as even. So guys, it comes down to you, let's drop it here too. What is the cosine from the unit circle? Who recalls what the cosine of 2 pi, the x-coordinate at 2 pi on the unit circle is? 1. And I've got a -3 out front times that 1, and I end up with a -3 for an answer. Then I look back at my graph, we're talking about this point here, is my graph short enough down at -3 for a check? Does my answer agree with the graph? Ooh. Now, June, feel a little better now? That's the way my exam would have looked if you had an exam on this trick. Now, I've done this, I did a graph, I did something with a double angle formula. One more thing I'm gonna do, then you guys might have to ask some questions here. I have one more item to look at. Okay, guys, I don't want to erase that, I'm over here on the side of the board here. Let's solve this. If possible. Looks like that. That's a simple one. Another one here short. Sine double theta, subtract 4 is equal to -3, like algebra. Solve it. I would think you'd move that over first and change this right quickly into that. That one. Let's try to solve for theta. What do we do now? Yeah, 2 theta. And you ask yourself, where on that unit circle have I seen sine equal to a 1, the y coordinate, because that's going to help me here. With the pi over 2, that says that 2 theta is representing pi over 2. Now I'm going to put the period numbers just in case I need it. There's many answers here. 2 pi k. K, element of these. Choose that will take care of all of them. Remember that period number that makes things repeat? That will take care of all the answers here. Divide by 2, and you're going to end up with a solution that looks like this. This is a general solution. Pi over 4 looks like Two's canceled over on the end, leaves me pi k, where k is an element of the integers. There's my solution. By the way, does anyone think of another, point on that circle besides pi over two where sign is one, or is that the only one? Oh, doing good? No. I think down 270 is negative one, isn't it?
Yes.
Yeah.
Negative 3 pi over two.
No, not quite that. Directly on the unit circle. We're not just directly on the unit circle.
Just one.
Have you seen, there's only one spot, it's 5 or 2. If there was another spot, you have to go through this again. Consider the other one. With that you're seeing staring on this one, if I say please list 3 answers, notice I did not put this. I may put this and restrict you tomorrow to list only the answers that fall there. If so, the answer is 5 or 2. If I say no, just leave it open, list as many as you can. You say, well, that's where you want. Well, this is where you let k be 0. I usually start with 0. Go back, put a k to be a 0, the second term drops out, and your first answer is pi over 4 to consider. If you let k be 1, cute. Theta in this case, letting k be 1, replacing k by 1, guys, that's pi over 4 plus pi. Help me out. What's pi over 4 plus pi when I replace k by 1? Is that 5 pi over 4? Help me out. 5 pi over 4? That's another answer. I say list 3. Let's try one more. And k is 2. Put a 2 in there, it's pi over 4 plus 2 pi, help me out. 9 pi over 4. All of these would work. Now though, like your textbook, if I do say no, I just want to caught here, which of those would I accept? 5 over 4, 45 degrees definitely is in there. Is that 5 pi over 4 okay? Is that within 0 to 2 pi? That's true? And the 9 pi over 4, is that in there or not? Here, see the head shake no, so just list the ones that are caught in that integral, guys, looks like it would be these two. But you would not know how to do it unless you recognize the sine double theta formula. Woo! Or in fact, we did not even use the sine double theta formula on this one. We could have. Make sense? Ooh. Now, look at the clock here. I did a few. You know you're responsible for everything, except induction. Please, someone ask me, I've got a few minutes here. What else are we concerned about? I did a graph. Are you concerned about maybe a graph of a secant or a cosecant where you have x cannot be equal to those asymptotes? Remember, you give a formula for those asymptotes. Should we look at one of those before you leave? I think we should. Does anyone have one handy there? Maybe even when we've already worked in class, and then I'll stop with that. Maybe a secant or a cosecant graph. I'll be glad to graph it for you, discuss it with you. Anyone? Anyone go back to your notes and see which ones did I do? Because I know I did a cosecant. Did I do a cosecant? Leave that to me. Oh, I call it h of x, okay. 2 cosecant.
Pi over 4 minus x.
Like this.
Yes. Plus 4.
Oh, plus more, plus what?
4.
Oh, yes, we need to see this. Oh, yes. And you said, did I do this in class before? Or was that just on the handout? Oh, beautiful. We'll do it. Guys, just clean this up. Rearrange it. Take out the negative. Have that x completely by itself. And I'm stepping back and looking at it. I think it looks like that inside there now. Does it? Now, can you tell me, over there cosine, I was doing cosine over there, I think. No, was it doing cosine? Down my graph. I was doing cosine and cosine was even, and we got to drop the negative sign. Does anyone recall what cosecant, not cosine, cosecant, is it even or odd? Odd, oh, this is beautiful. So I'm not allowed to drop that negative sign, but I can do this. And rewrite this as negative 2 cosecant, left hand side there's this. Ah, nice. Rita, I'm glad you asked. Now it looks like that. Is that true? Now, I think she may do hers tomorrow on the test, from what she's told me in the past. She may do hers with transformations. It's up to you. It's lengthy. Oh my goodness, you have to reflect across the x-axis, you got to stretch by 2, you got to horizontally shift to the right pi by 4, and all of a sudden the vertical shift up 4. Good luck. Those are all the transformations. Philip, oh, bound this. Let's take this argument, and notice that plus 4 is not part of that argument. I got to bound it. You think it would be wise to go ahead and bound it between 0 and 2 pi again? Can we try that? Always between 0 and 2 pi, we can try that. Let's try it. And have it like this. Oh, this is nice. Try to bound that argument between 0 and 2 pi. Notice I did not put, where's my bounding over here on this one? I think I bounded this one between 0 and 2 pi, but I put an equals mark with it. Why can I not put an equals mark on this one? I think we're going to have asymptotes. Which can't be included. Okay, let's finish this up, guys. Find out what it is. Add pi over 4. That's solve for x. Do not mess up. 2 pi plus pi over 4 is at 9, I think. Those are the bounds. Wow. You will find the period. If all that's correct, right quickly. Take the ending of that cycle, subtract the beginning. That's 8 pi over 4. I think it has a period of 2 pi. Wow. So at least I know the period. Now, should I go ahead and divide this by 4 and get 4 for my spacing? See what the spacing is? It's not going to be too bad. Okay, take 2 pi, period, divide by 4, reduce that down, so I'm spacing by pi over 2. And here we go. We're going to have a crack. See what this looks like. Wow. Let's see. Okay, guys, looks like we're supposed to start at pi over 4. Over here. End at 9 pi over 4. And space by pi over 2. Is that true? Pi over 2? Would it be wise to do what? Change that to maybe 2 pi over 4? Because I see those 4s over there. And my spacing would be much easier to deal with it like that. So guys, let's start adding 2 pi over 4. So we get 3 pi over 4. 5 pi over 4. And 7 pi over 4. And of course, 9 pi over 4. Is that true? Nice little graph here. I'm glad she asked. Now, woo! I have a vertical shift up 4. Bothers me. Here we go. Wearing down here. Guys, we're going to show that because that may play a part here shortly. It's a vertical shift up 4. It's up here. And move the Bible. shift. That's taken care of. That's taken care of. Only thing I need to worry about is the effect of this. Now, she's given me a cosecant graph. Do we recall what a parent cosecant graph looked like? I think I did it the sign. Was there one piece looking like that? All of a sudden, another piece looking like that? Remind me, please, for a parent graph. June, this one, because of that negative sign, might be flipped over. And stretched by 2. True? Now, I'm up at 4 already. I'm going to see what that stretch may do for me. It's going to take me up to 6. I stretch by 2. And down to, I guess, 2. 6 right here. Get ready for it. And I think I said 2 here. Okay. Right? Now let's get the graph and we'll be finished here, guys. You guys have worked hard today, the last day here. Pi over 4, does anyone think they know what is happening at pi over 4? And how does one tell? Because these are the types of graphs that may have asymptotes. Do we start out with an asymptote based on what your parent graph did? Philip's saying, Professor, I think we're going to start out right now with this. We will check here shortly. He thinks there's an asymptote immediately. If there is, I would think the next one might be where? That jumps over here. But we'll check it for you, Lee. And I would expect probably the last one over here. You guys, is that true? Now, where's the graph? Well, the graph at 3 pi over 4 is supposed to be, let's see what's going to happen at 3 pi over 4, guys. Where is it? And tell me what's happening. It's going to be upside down compared to the parent graph. I think my parent graph looked more like this. Did it look like this on the parent graph? So what do you think is happening here in between? Here.
It goes down from 4.
It's going to go down. Is it going to go up to 2 though? Because we said 2 was involved.
Yeah.
Is it going to go up here? This is strange. Put it in green here. You tell me right here. It might be doing something like this. And then the other piece might, since it's upside down, at 7 pi over 4, guys, where is it? Is it up here?
6.
At 6, doing this business. And of course, they're supposed to be symmetric, and they certainly don't look symmetric there. It's supposed to be the same type of shape there, guys. You think so? Woo! Now, before you turn your test in tomorrow, if you saw one like this, we're not quite finished with it. Almost finished myself. Pi over 4, is it truly an asymptote? Philip, you say it is. And I go back real quickly and put in pi over 4 right there. Just for a quick check. This becomes 0. And then it says take the cosecant at 0 on your unit circle. Now I think at 0, the ordered pair was that. Is that true? And what is cosecant? It's supposed to be what, 1 over y or 1 over sine? And is the y 0 here? So you're placing what, 1 over 0, 1 over y for cosecant? Is that undefined? Which says yes, you're going to start out with an asymptote. I just quickly took pi over 4 back and just did a quick check to make sure there was an asymptote there. Philip?
Can't we also see that from the bounding?
Yep, you can. You can, which you did. I just did a check to make sure. Guys, if that's the graph, oh my goodness, here goes domain. Down here. I need your help. You've been helping along with this equation for an asymptote. X cannot be. That's pi over 4, 5 pi over 4, 9 pi over 4. You need to write an equation for me.
So it's around.
We need to write an equation. So I can pick up all of them. Anyone have an idea? Now, by the way, if you want to start with pi over 4, that's where the first one is. I would do it like this. How much spacing is there from here to here to get to the next one? pi, 4 pi before, there's also 4 pi before to get from here to here. So that would help me to write this. So 4 pi before is what, pi? If you add pi to that, that will be where the asymptotes are located. Like what, write this as what, 5 pi before, I guess? True? So x cannot be, you end up with, whoa, hang on now. X cannot be equal to that, how did we write this, with a k?
By K, yeah.
With a k? Where k is an element of what, the integers? Is that what we did? I think. Let's see if we did. It's not gonna work. If I put a 0 in here, oh, wait. If I put a
You just
0 in
said
this,
it's
becomes 0,
0.
right? You think it's an asymptote out here at 0 if I should have gone to the left? That's what my formula says, there should be 1. By the way, if I put a 1 in here, I get what, 5 pi before? Did we short up get 1 here? If I put a 2 in here, I get 10 pi before, we got 9 pi before. We're off.
In formula, we need to write 5/4 plus pi k. Yeah.
Okay. Joseph, what was that again?
That was what he said.
Hang on. X cannot be, name it for me again.
5/4 plus pi k.
Pi before plus pi k. I think you guys said the spacing there was pi, wasn't it? This is what we want, where k is an element of the integers. So I'll start with the first one, spacing was pi, that's where the pi comes in, and any number of times put a k there. Now replace k by 0, and you get pi before. Replace k by 1, I think you'll get this one. K by 2, you'll get this one. That's a good way to think of it. Start out with one of those and see what the spacing is, and put a k there. You got it. Range, if this is correct, guys, it's negative infinity up to what number? Looks like 2. And union, what was that, 4? To infinity. Domain, range, was it 6? Not 4, 6. It's up here. Is it now reading correctly? Woo! Did we get the period out of the way? We found the period, didn't we? Earlier, 2 pi? No after 2 in a bracket or something. Oh my goodness. Jeez. Now, I'm closing down. Now that you guys are tired. Now I'm tired, you're tired, we're all tired. Rough 6 weeks we got done. Philip and class, on this graph, I'm writing the word staring at it. I will try one thing, we're gonna say goodbye, I'll see you tomorrow. I'm gonna ask us to do this. Let's try to find f of, here we go guys, we'll just choose a point. Let's try, what's it, 7, let's try 7 pi over 4. Just randomly select one of those numbers. Let's try to find f of 7 pi over 4. Use green here. Better. Now, I've erased my function. Help me out. Was there a negative 3 up front?
Positive 2.
Oh, right, positive
2.
2. Positive 2. Then I had what? Cosecant, was it?
Cosecant.
Secant? Oh my goodness.
Cosecant.
Was it cosecant?
Cosecant.
Yeah, cosecant.
And then it's pi over 4 minus x
5 over 4 minus x.
plus 4.
Now, I've enjoyed this class so much. Mr. Park, June, if I now find this with this function, and I do not get an answer of 6, I may just start crying. The graph says the answer is 6. Here goes. 2 cosecant 5 over 4, and I'm replacing that with 7 pi over 4. Red. Close that up. Guys, do not let me make a mistake. do cosecant. Inside there, pi over 4 subtract 7 pi over 4, help me out. Negative 6 pi over 4, reduce down to negative 3 pi over 2, I think. Plus 4. Oh, back twos. It's not looking good. Is it gonna work? Again, I'm about to cry. I have to close it down, I was hoping to get a 6. Is it gonna give me a 6? Joseph said, Professor, it is gonna give you a 6. Joseph, tell us why. Now, let me again, cosecant of negative 3 pi over 2. Guys, I cosecant negative 3 pi over 2, help me out. If I move backwards negative 3 pi over 2, where's that land? At pi over 2? Is it? So is that 1? Yes or no? Joseph, you're telling me that. Okay, save your tissues. I'm gonna cry. Looks like it works out. Does it? Guys, good luck. And keep in mind, check room 63 tomorrow, so I'll be here at 11:30. And Mr. Parks, Tiffany's gonna be here. June's always here. She's in that math lab always. Okay, guys, good luck.